talking about graphing linear inequalities. Okay, so there's the vocabulary. The vocabulary is going to make some more sense after we start graphing. Now, we're not going to graph any differently than we've been graphing. So there's actually two ways we can graph besides the intercepts. We can use a t-chart like we did at the very beginning of the chapter, or we can identify the y-intercept and the slope and graph. The only difference is instead of having an equal sign, we're going to have an inequality sign, which just means our finished graph is going to look a little bit different than the graphs that we have done prior to this. Okay, so I'm going to give you a chance to finish writing down the vocabulary words. And instead of graphing 2 lines today, we're only graphing 1. So yesterday we graphed 2 at a time, but today we're only graphing 1. I think the first part, the first example is going to be very familiar because it's not very different from what we have done previously, and then also at other times during the year. So let's just go through.
The stuff that we substituted.
Yes, substituted. So example 1 are just yes and no questions. They're just yes and no or answers. The answer will be a yes or no statement. So what we're going to do is the directions say tell whether the ordered pair is a solution of that equation or that inequality. So it's an inequality. Now, all we have to do is replace the x and the y with the ordered pair that they give us. So, in A, instead of writing 3 times x minus y is greater than 2, I'm going to replace x with 3 and y with 0. So I'm asking myself, what is 3 times 3? And what is 9 minus 0? Is 9 greater than 2? So the ordered pair 3, 0 is a solution to that inequality. Is there more than one solution to that inequality? Yes, there's always an infinity number of solutions available for that make that inequality statement true. Now on this one, instead Is 11 greater than 4?
Yes.
Yes. Okay, so this is a solution. So I would just say yes, or true. Okay. Is 3 greater than 4? No. Is 4 greater than 4? No.
But if it had like the little
If it had this, yeah, if it had this, then it would have been yes.
more or the same.
Alright, but it didn't, so the answer would be no. Alright, now, I'm going to go through this little box with you. It's not going to make as much sense until we go through the example. Okay, we are going to graph an inequality. We graphed it using the slope-intercept form, where we find the y-intercept, we find the slope, we plot the points on the line. The only difference is that, and that's just like we would if it was an equal sign. The only difference is how we draw our line. If the original inequality had a less than or a greater than sign, instead of connecting the dots with a solid line, we connect the dots with a dashed line, or a dotted dashed line. Now, if the inequality is a less than or equal to, or greater than or equal to, we graph it with a solid line, just like we would if it was an equation. Okay, solid line. Just like, remember when we graphed less than or equal to, greater than or equal to, it was a solid dot. Okay, and then if it was greater than or less than, it was a hollow dot. Okay, so same thing, except since this is an equation of a line, or an inequality of a line, if it's just less than or greater than, we use a dashed line. If it's greater than or equal to, or less than or equal to, we use a solid line. Now remember, with an inequality, there's a whole set of numbers that make the statement true. So with the graph of an inequality, there is a whole set, there's an infinity number of ordered pairs that make the inequality equation, or inequality true on the graph. Yes?
So, are we going to still need to draw like a little bubble?
No, this is a little different. Okay, because this isn't a linear inequality. So this is it's like a linear equation, except it's a linear inequality. Okay, so now pretend like you don't see the graph. Okay, we're going to treat this right here. This is a linear inequality. The only difference between this and this is our final graph. Okay, so I'm going to graph this just like it was this. Now, how do I do that? I identify the y-intercept. Where does this line cross the y-axis? 0, 1, which is right here. Now, what is the slope? -1/1, which means I'm going to fall 1 and run 1. Fall 1, run. Now, I'm going to go ahead and reverse it so that I get a nice big line. Now, look at the inequality symbol. What is it? It's greater than or equal to. So I'm going to draw a solid line. I'm going to connect my dots with a solid line. Okay? I'm almost done. Okay? Now, solid line. on the graph. It depends on the graph. Okay, so the next page is what happens when it's just one variable. Well, we graph it just like we would if it was an equal sign. Okay? So this is x is greater than -2, and this is supposed to be less than or equal to. Okay, so we're going to graph it just like it was x equals 2, using what kind of line? Is it going to be side I'm going to replace y with 0, and I'm going to replace x with 0. And I'm going to ask myself, is 0 greater than 0 minus 3? Which means, is 0 greater than negative 3? Yes. Okay? So since this is true, I'm going to shade everything on that side.
So from the line over?
From the line over, yes. Not from 0, 0, but from the line over. Alright, the last one is x is less than or equal to 4. So I'm going to graph it just like it was this. So I'm going to find where x is 4, and since there is no y, it has to be a vertical line. Now, is it going to be dotted or solid?
Solid.
Solid. Now, I'm going to test the point 0, 0, which I only have x. So I'm going to ask myself, is is 0 less than or equal to 4?
Yes.
Okay, so since this was true, everything on this side of the line and on the line is true. Now, I'm also going to give you another example. I'm going to work out one of the problems from the homework with you. So if you'll flip to practice A. Oh, I did it on here. Somebody, I'll call it out. That's on here. Okay. So if you look at number, I think let's do number 10. Number 10 is y. Okay. Y is less than or equal to x minus 5. Okay, so I'm going to graph this by starting at the point 0, negative 5, which is right here. That's my y-intercept. Now, what's my slope?
1 over 1.
1 over 1. So I'm going to rise 1, run 1. Rise, run. So, now, is it a solid line or a dotted line?
Solid.
Solid line. Okay. Now, I need to test the point. I'm going to pick the point 0, 0 to test. I'm going to replace both x and y with 0. Is 0 less than or equal to negative 5?
Less than. No, more
Yes.
than.
Wait. No.
0
No.
is not. This is not true. So since this point right here is not true, I'm going to shade everything on the other side.
This should make graph
So if it's
bigger
not true,
already.
you shade on the
Opposite side. Yes. Okay. I'm going to do number 7 real fast too. So number 7, this line starts at 0, negative 2, which is right here. What's the slope? What's the slope? So I'm going to rise 1, 2, 3, 4, 5, run 1. Rise. Okay, and I'm going to reverse it. So that I have that nice line there. Now, is it a solid line or a dotted line? Dotted, right? So dotted line. Now 0, 0 looks a little too close, right? I'm not really sure if it crosses there. It looks like it's to the left of the line, but since it's close, let's pick a different ordered pair. Let's pick 2, 1, and let's test that point.